Okay, welcome everyone. Thank you for joining us this evening, and apologies again for the reschedule. But I am personally also looking forward to this session on GitHub. So I'm looking very, very much forward because I don't have a lot of background in it. So I'm very grateful to have Dr. Khao here. So just a quick one, a special thanks to our sponsor, the National Institute for Theoretical and Computational Science. Uh, so my name is Katlejo, and I'll be the host and as well as co-host for today's session with Dr. Khao. Okay, cool. Introduction to GitHub.
Thank you.
Dr. Khao is the executive. Oh, sorry, Dr. Khao. Dr. Khao is the executive head of data and information management at Old Mutual Limited, and extraordinary lecturer at the University of Pretoria. He has a PhD in mathematical statistics from the University of the Free State and extensive technical and executive experience in data science, software engineering, and statistics. Thank you, Dr. Khao, for joining us and hosting us today with this lovely topic. And we are now officially in your care. Thank you.
Amazing. So it's probably going to be a long two hours. I just want to start by apologizing firstly for last week. So I was in China. A little did I know just how much internet access you can manage to get without VPNs.
Yeah.
And changes in time zones as well. But thank you everyone for joining. I mean, this is going to be an interactive session, which is going to be discussing introduction to GitHub. Git, not GitHub, but GitHub as well. I think it's important to note that oftentimes we can immediately just move straight to SaaS solutions, or what they call software as a service. But it's also really good to understand the fundamentals of the solution itself, right? So I always start with, let's look at how this thing actually works, how it behaves, understand the core concepts. And then it becomes super easy if you need to go, use SaaS solutions, because they get quite advanced. And so knowing the fundamentals really help. One of the benefits that I can mention about using version control is an obvious one, right? That if you are working with multiple teams, surely you need a way to be able to manage all of that, all of the changes that are happening. And so we're going to be, doing simple exercises. I am a certified software carpentry instructor back in my academic times. And so I used to do such workshops and just introduce people to novel technologies like Git, R, Python. I don't use it now in my new job, but my team certainly do. And we tend to collaborate on a few things. So, I mean, if you look at the notes that is presented there, and everyone should have access to this, I assume, and have access to the YoPad. We'll just use the YoPad as, an interaction feedback session. When we do exercises, you just put your stuff in there as well. I assume everyone has access. I can't see hands or anything. Cool. The one thing that I would like everyone to do, which would have been great if I actually asked before, is I don't know how many people are using Windows and how many people are actually using Mac. And I find that because Mac is a Unix-based system, the stuff is easier for me to go through, but difficult for some Windows people. So in the notes, you will see there when you hover over to, I'm just going to try to collapse this. If you just hover over to installation or setting up, which is number 2, there should be some information there on how to set this thing up. Actually, I can't find it, so I'm just going to go straight to Windows Git. So if you can just download, if you go to Windows Git, you'll see, for those of you that use Windows, if you can just install that command line, it's a bit easier to work with than trying to do it directly from your Bash terminal. So pick whichever one. I don't know what your Windows machine is, but I would assume everyone should be on Windows 64-bit. If you're using Mac, you don't need to install it. It should already come with your Mac. And then just give me an indication if you're struggling to actually download this. Right. So, and then after you download it on a Windows machine, I mean, you'll get, you can just search it, right? If you just go Git, something will come up, and then just open the Bash program, not the GUI. So don't download the GUI. Cool. And then I'm just going to start with some simple Bash commands. But before I do that, let me just explain, right? Like, in as much as you do get these software as a service tools like GitHub, Bitbucket, GitLabs, and all of those, if you are working with files on a cloud, files on a server, and other, worse environments, it's always good to just be able to SSH into the machine and still be able to do version control without having to worry about not having a GUI or a screen. So that's one of the benefits. So I'm just going to show a couple of commands that I think you might need for the exercises that we're going to do. Generally, Bash operates within some directory that you will be in. It will either be in home. So if you're a user and your name is Gao, that's probably where it will live. One way to try to assess where you are is to use the command ls. So that will locate exactly which files is in the directory that you're in. And if you want to know the exact directory, you just type out pwd. So that will give you your working directory. And then for the stuff that we're going to do, obviously you want to work within a specific directory for the rest of the workshop. So figuring out where you are and what's in where you are is super important. But then you also need to know how to get to your directory. So to do that, we use the command cd. If you are, I would assume it's the same on a Windows machine as well. But if I do cd and I type tab, it immediately gives me the list of files. And then if you use tab, it will just autofill the actual directory that you want to get into. So in my case, I'm just gonna do everything on my desktop. So I'll just say desktop. And so now if I check my directory, pwd, you'll note that I'm in my desktop. All right, I'm just gonna ask that everyone, and then I'm gonna delete it, right? So just give me an indication of if everybody has got the Git installed. If you're on a Windows, it works. If you're on a Mac as well, you can see that the stuff works. And then I'm going to start picking on people. Dumisang, is yours working?
I think the journey of clicking this wizard, a lot of options, and so on and so forth. That's
too many things as well, right?
Yeah.
Cool. But I'm just gonna put all the commands that I'm gonna be using over here so that you all. Oh, somebody's already started actually. So pwd. Let me know if my screen is too small. To check your directory. And then using ls to check what's in that directory. And then just using, so cd is just going to change working directory. Cool. This is all we're going to need. The last one is probably make directory. So if you don't already have the directory, you can just use mkdir. For example, I know I'm in my desktop, so I can create a folder called, whatever. And then I can cd inside of that directory because it's a mess on my desktop. That's the only reason I do that. So if I cd into that directory, what did I call it? Whatever. I check what's inside. I note that there's nothing in there. So some basic commands to familiarize yourselves with. Cool. So let's get started. I mean, you can read throughout the story yourselves. It's a pretty fun story about, Wolfman and Dracula, but we're going to be referring to this quite a lot. But the most important thing that I want to focus on in the just to respect time is the concepts themselves. So what we're going to do, I'll just walk you briefly around automated version control, how you set it up, how you create directories or repositories, sorry, how you're going to be tracking changes. We're going to be exploring history a lot of the changes that you make, how to ignore files. We'll do some remotes, and this is where we introduce GitHub. And then how do you collaborate? How do you manage conflicts? Because that's a big one. Then we'll discuss sort of like open science and collaborating on open source projects and what are the best practices there. So I'm going to delve a bit deeper into other things as well and some of the projects that I've gotten involved in. And then I'll just touch high level about the licensing, especially if you're building out open source projects. There are key considerations that you need to make to think about which licensing, because I mean you're going to put your stuff out there for free. And then citation, and then you can also host certain things that other people can use. And I've actually done worse, where I built my whole website on GitHub for free. And then we'll just do some supplemental stuff around using IDEs with Git. It is a lot easier than when I started using Git. So super excited about that one as well. And then I'll just share some of the best practices from my organization and other organizations that I've worked in how we do version control across sort of various projects and various other software as a service Git tools like GitHub, and at the same time working on Google, at the same time working on GitLabs. Hopefully we get there. This is supposed to be a 3-hour workshop, but we're going to try to compress it into 2. Great. Now I need some engagement. So if you can just go on the Yopad, I just need to get an indication of how many of you are doing this for the first time and how many of you are, you've sort of done Git before or version control of some sort. But you just wanted to hear a man in a red cap talking about Git. So if you could just let me know knowledge of Git between 1 and 5, more or less, where are you?
0 for
And by
me.
the way, this is color coded, so you can just put a number.
Yeah, it's 0 for us. Never interacted with GitHub, so I guess we'll see. We'll read the room, but I am excited. Looks like my installation is good. So
brilliant!
That, yeah, a lot of people are familiar with it.
Brilliant.
Yeah, it's also 0 for me. And I'm also struggling to get the pad. So maybe I might have to download it. Yeah.
You have to download Yopad.
Yeah, let me just see if I can download it.
No, it should be I mean, I assume if you just, it should just load. If you're using Chrome, it's probably easier.
Okay.
Oh, cool. Just try it again. All right. I'm going to go with the numbers that I have here and extrapolate that this is going to be the average of the population. And just apologies if my screen keeps going on and off. Somebody has their microphone on. If you don't mind just turning it off. All right. So let me go fix things and we get started. You should be able to follow. I think for some of you, if you still can't access your command line. The other thing that you might need to do if you don't already have it is just to set up a GitHub account. That's super easy. I mean, I think you can do it very quickly. If you just go to github.com, there's a sign up option on the top right of the page. And then, they've made it so fancy now that like you can literally just type in your email. After typing your email, it's not going to allow me because I already have. Let me try this one. And then you're going to create your own password. Make sure that it's strong, I guess. And then, you can pick a username. The username is pretty much what people are going to refer to your repo as. So if I go to my actual GitHub, you'll see the repo will oftentimes be referred to as ATW Gao. ATW was my module Actuariële Wetenskappe. Yes, it gave me so many nightmares that I named my email after it. And then after you type that out, there's so many of them, so it's probably good to add some numbers in there. You can opt out of the email preferences, and then you should get an email that allows you to sort of verify your account. And then just prove to this thing that you're not a robot. Cool. So I'm assuming that was super quick. I failed, it appears. So hopefully you guys get it right the first time. And this is only for the section that we're going to be doing later on. Right. So once you've got that sorted out, the first section, like I said, what we're going to try to do is just understand what is version control and why we need to use it. Tools are more advanced now. So, I mean, if you think of, for some of you that are, if you're studying and you're using LaTeX quite a lot, you will use Overleaf. And Overleaf, I mean, already provides you with integration with GitHub. So you should be able to do version control there. But pretty much the problem that we are solving is, I'm sure there's a lot of you that have had this before, where, like your final doc is not really your final doc. And you just keep, changing this document so many times. When I was still a consultant, we used to have this thing where we name files according to 2023, 06, 04, the, month, time, and whatever, name of the file. And then, you just put version 1 or version 2 or whatever. But I mean, this is very difficult to also manage. And especially if you're working with a lot of people. Now, all of a sudden, somebody has overwritten your, document, or they, removed it or deleted it or whatever. If you don't have recovery capabilities on your shared drive, that's a problem. So that's the problem that we're solving. And basically, you can think of it as, this is sort of this thing that's recording your document, ensuring that, you're tracking changes as you go, and exactly the version of the file that you're in. When was it changed? Why was it changed? Who changed it? Even if you use Word, and you tracking changes and accepting changes with your fellow collaborators, I mean, it's often difficult to see who changed the file and why did they change it, because they don't have to be clear on why they're changing the file. I mean, even something as good as Google Docs as well, they've got a version of a history. So if you're doing Word documents there, then you should be good. So your file is going to go through multiple life cycles. Oftentimes, what we use Git for is plain text files. So if you building an application or whatever, and you've got tons of code in a repository, I mean, most of it will be text files, so flat files that need to be compiled into code. And so hence you will see a lot of programmers using it more so than the general population that's using PowerPoint or any of the other tools. Cool. So the other nice thing is, the file can be, you can think of the file as then being able to be duplicated, or not duplicated per se, but have multiple replicas of the file. So, multiple people can make changes to that file and keep that version on their system at a point in time. The one thing that becomes a problem if you are dealing with multiple people changing the file is that you can run into conflicts. And so if you think of a conflict in the context of Git, if I typed something over here and over here, if I make changes to the file here, things should be fine. But the moment I change here and someone is also changing here, then you've got a problem, because then, we're all editing the same file at the same spot. That's going to raise a conflict, and you're not going to be able to bring back the document into one. And then basically how you create those different versions is we'll go through something known as commit. So that's how you commit your changes. And once you do, it will save some really important metadata about those changes. For example, why did you do them? And there are some best practices around how to detail the reason for why you are making those changes. And basically the complete history of your commits in a particular project, and all of that metadata, that's what makes up a repository. I just like to think of as a repository as a folder. It makes it easier for me to think about. But a repository, once it is it has been initiated, will have a bunch of metadata about everything that happened in that directory that you staged or you committed. It's not like Word, where you're just going to be, it's going to auto save and all of that stuff. It's quite manual. Hopefully over time, I guess these things become better with the advent of AI. So Git was not the first or the only version control system. There's like others, right? Like RCS, CVS, I think concurrent versioning systems or whatever, and subversions as well. And these date back to the beginning of time. 1980 is not the beginning of time, but it's quite far behind. Git is more of a modern version control system. It was actually invented by Linus Torvald, I think is his name, the man behind Linux. And if you know Linux, you'll know this is it, right? This is what they had to work with at some point in time. So there's multiple files that needed to be versioned and managed, because again, multiple contributors, multiple people working on the same thing. So I mean, there's a simple exercise here that you can look at, in your own time. It's basically around the possibility of retrieving something that you had drafted, but then you ruined it. And this is without thinking about Git. And then just imagining that you've got multiple authors working on a document. What would happen if you track the changes? It's actually better to actually do this yourself and try it, and see if the tool is there yet. To set up your Git, I mean, it's quite easy to set up Git if you use their CLI. But if you can't, please let me know so that we try it this way. How I usually do it is I use their GitHub CLI, which is already, I think, comes pre-installed in most MacBooks. But if not, I just brew install it and it works. The command is GH. And if you can't, I mean, just let me know, and then we just do this longer version of doing it. Okay, I'm gonna assume not everyone can do it. So basically, how Git works on the command line is you've got the preamble Git, like it always starts like this, right? And then after the preamble Git, you will pretty much have what's known as a verb. So the verb could be anything, and I'll show you just now how to get help to figure out how many verbs there are. And then after that, you will have a couple of options. So I'm just going to say options. And then you will have options in here. It's very easy to find out what's available, what verbs are out there. You see, if I type Git and I just use -H, it will immediately just give me a couple of options just to know, okay, what do I do? What's out there, and like, what does it mean? All of these things are super important. Some of it will probably not get to them today, but it's just important to know. If you need help, just go Git dash and then H. So the first thing we want to do is to configure our Git. And the reason why you do this is because you need to be able to have a name so that we know exactly who's changing a file. And usually when you change this on a global level, which is what we're going to do today, then it's throughout the system. Git already knows what your name is and what your email is, and then it makes for easier authentication. So if you just add the option global, what it'll do is it'll give you some key value pairs. The first key is going to be what is your name, and then you just type it out. In my case, and then once you press enter, that's already there. And then you do the name for config for your username, user email. Again, use your email that you used when you set up the account at gmail.com. And then done. You should be done now. So again, like I said, these will be associated with your all the activity that you do, so we know exactly who's making changes. And when you push stuff to your cloud version control systems like GitHub and GitLabs and whatnot, then everyone knows exactly who's making changes. And obviously you would have authenticated, so we're not just going to have random people adding onto our code and breaking things. Great. I hope everyone has got that figured out. There are some various other things that you can do to authenticate and configure your credentials. You can have a look at them depending on which tools you're using. But if the first one worked, then you don't have to worry. And then the other thing is, very importantly, you might not know if the thing worked, right? So if you go git config and then the option is list, it just gives you all of the different configurations that you made. So in my case, there's my email, and I'm assuming somewhere is my name. There you go. Again, another thing to note, I tend to delete stuff a lot on my terminal. I'm using Control L for, or Command L for Mac users. I think for Windows it'll be, I think you just type CLS or something like that, or Control L would work. Great. So that was the main thing. You've got to be able to configure your Git so that it knows who you are. If you are using, let me actually not get to that, like try to finish this other stuff much earlier. So now what we're going to do is try to create a repo. Where are we going to store information? How is that thing going to be created? And can I just do it on my machine? And then later on push it out? Like there's all these options, right? And we're going to keep on going back to this nice little story of the werewolf and Dracula. So what I want you to do is just try in your machine to get to your desktop like I did. So if you remember, I tried to check where I am. If you're already in desktop, that's fine. If you want to get to a certain directory, you use CD. And then if you press tab, it should give you a view of what other directories are out there. But if you don't want to do that, you can type ls, and that will give you the mess that you see on my screen over here. If you make a mistake and you go to a file that you didn't, or a directory that you didn't want to go into, it's very easy to come back from that. You can do CD and then with just 2 dots and a // it will take you back one parent, to the parent of that directory. If you want to go further up on that directory, you just add more dots. This will be 2 steps towards your parent. And now, as you can see, if I type pwd, I'm lost. So I'm just going to try to get back to my desktop. And then I want you to create a directory called planets. Right? Sorry, the command that I typed is make directory planets. And then I'm going to go into planets where things are going to be much neater. As you can see, I have nothing in there. So generally, how we create files, again, because it's dependent on your system, I will oftentimes ask you to create files directly. So just go straight to that directory using Windows without being too fancy. So if you just, go to your desktop, check, you've got the directory in there, planets, go in there, and I want you to create files directly from there. Otherwise, if you have what I'm going to show you now, then it makes life a lot easier. So I'm going to create my repository by instantiating it, with git initiate. So if you type git init, you will see that empty repository, it's initialized. So we're all good. If I type ls, you would think there's something in there, but there's nothing. But if I type lsa, you will see there's actually a file. It's actually a directory called .git, but it's hidden, so you will not be able to see it. If I go to my folder planets, you'll see there's nothing in there. That's because it just hides the file, because it doesn't. Otherwise, it's going to be messy. Cool. So just a few things to note there. And then the other concept that's probably important that you might want to get or familiarize yourself with is the idea of branches. So, in Git, you have a main branch where, the main files tend to live. And I'm going to make an example because it becomes easier for me if I explain it like this. You're working on a software project. The main file or the main folder is going to be called master that we're going to be tracking. So you've got master. So you can think of master as this now, main branch where all of the different files that we work on are going to be living, right? It could be various files, Python, R, whatever it is that you program with, or LaTeX. So all of these files are going to live in your master branch. But because you want to be able to manage the entire project, so you don't want to just, be version controlling one single file. I mean, there could be in some of the projects that I've been in, you can have, something as close as 1,000 different files in there, right? So all of the files will live in master, sort of like your main repository. And you've got this ability to then branch out to a repository, a branch, not a repository. Maybe let's call it dev. That's where you're going to be doing your development work. So these are best practices in software engineering. They'll, do everything in dev. And then maybe they'll have another one where once it has passed a few tests and we're sure that your code is perfect, then we'll pass it on to a different branch. I think the next one that they like to use is QA, quality assurance. And then, what ends up going into master is then, code that's production ready. Or some people just go to a different branch called production, so that we know that this is, no one should be messing with this. This is applications that are, customers are looking at. So the idea of branching is really great. And also, sometimes even in dev, you're just working on a simple feature. So we ask you to go write a simple paragraph, or we want you to go build a feature in a website that lets me, I don't know, click a button, right? So oftentimes what we'll do is we'll name a new branch and we'll call it something like a feature, whatever number you want to give it. And then you just explain what the feature is, button generation or whatever. Right. So the great thing about this is, then you're working in your feature and it's not messing with the master or the development branch. And only when you're ready and you push everything that you've been working on into the development branch, then, everyone can sort of trial out your code. If it doesn't work, we just fall back. Yeah, you don't mess up the whole system. This is not the main point of today, but I just thought it's important just to cover the basics of branching and why it's important. So generally, master in the Git world, they'll some people call it main, some call master. This is to a simple example where we just check out a branch that we're already in. So you'll type checkout, and then you'll, if you say main, it will say switch to main. But of course, we already know we were in main. The default is always main. And if you want to check which branches are available, if you type git branch, you'll see there's absolutely nothing. So if you want to create a new branch, you generally say branch, maybe, I don't know, dev or whatever. Sorry. Switch to B, git branch, dev. Oh, The object main is not available. Oh, that's a shame. Okay, so the other thing that's super important is when you're dealing with the files, we're going to be using status a lot. So status really just tells you exactly what's being changed, what are some of the things that have been committed, what are some of the things that haven't been committed. So it's just a great way to, keep track of, just making sure that everything is set up correctly. So in my folder, if I go git status, you'll see that there's absolutely nothing going on. So I'm on this branch. I don't have any commits that I've done. So there's absolutely nothing going on here, right? So what we're going to be doing next is just making a file and then making some changes to that file, and then seeing what happens, right? Again, in the interest of time, I'm just going to ask that I sort of just flash through, these exercises, and you can try them. We've already done a lot of these things. This is basically just you creating your own repo, and connecting some of the mistakes in the file, and seeing what happens. Great. Now you get to do the fun stuff. So how do you then record the changes in Git? Because I said, this thing is not going to auto track your the changes that you're making. So how do you record the changes? How do you check the status of your version control repos, like whatever's in here? And then how do you record notes about those changes as to why you did them? So we'll just explain that entire stage of the cycle, how information gets stored, and then just go through how you modify and you stage all of your files, and then commit the files, and at some point we'll get to pushing them into GitHub. So again, you want to make sure that you're in the right directory. I know I am, so I'll type in pwd. And once I'm in there, you'll see here that they use this command nano. Well, that's because, so nano is it's a software. You can pretty much do these things yourself, but just try to do nano mars.txt. And if it works, it will open a completely different view in your terminal. And this view is the actual file that you want to edit, right? So in there, you can type in the same text, cold, dry, whatever it is. And then what you can do is press Control X. You'll see there. That's how you exit. You can write it out, but I usually just exit, and then it will ask me if I want to save, and then I just type yes. So you basically press Control X to exit, and then you just press the character Y and press enter, and it will save your changes. Now, just to make sure that we're doing the right thing, if I go to my folder over here, you'll see I've got Mars. If I double click in it, these are the changes that I've just made. So again, if Nano is not available on your system, you can just go in here and just create a file directly in Windows, or create a file wherever and just save it in here. Cool. Now that that's done, you can just check the file. We know it's there. That's great. And then, there's various ways to check what it contains, and you can use cat if you want. I just open the file directly. And then you can check the status of your Git repository. So just remember, status is actually talking about the entire repo and what's going on in there. And it will tell you all sorts of things. One, you haven't committed anything yet. you have stuff that is there, but is not tracked because, the way that Git works is if you want to track something, you need to be clear about, okay, this is my file. I'm going to first put it into staging, right? Staging just means, okay, the file is ready to be committed, and then you commit. So once you commit, then the stuff is ready. Sounds like a lot, but I promise you, stuff gets easier. And just to, I guess, give everyone some hope as well. This is an example of like something that I was working on. This is GitHub, the GUI. And things are way more easier here because you'll just type in the summary, the brief, and then you'll just click the button and that thing will commit, right? But it's just about understanding the concepts for now. So we're going to stage the file, and then we're going to commit at some point, right? How do we add the file? Well, the verb is add, and then we just list the name of the file. You'll note that usually what I'll do is just type the name and then press tab, and the thing will just complete the sentence for me. And then if it does nothing, you're doing something right. Again, just do status to see what's going on. And you see now the changes to be committed, not committed, is file. One thing to note also is that the reason why we do this is if you've got multiple files, right? Maybe all you want to do today is just to commit changes for one file in a larger software project, right? You just want to do this one. So if you stage one file, that's the file that we know we're going to commit. Then, you don't, you basically do away with the risk of pushing in things that you don't really want to push. Or maybe it was just, your own file that you're working on, or maybe it's called notes that you took somewhere, but you don't really want to commit these things, right? So you don't stage them. So the whole staging thing for this file will not happen because you just staged one file. So our file is ready. It has been staged. Now, the next thing that we do is we just commit the file, right? To commit, again, you just use the verb commit. Here, you just need to use one option, which is message. That's what it stands for. And then you just type out your message under yeah. So I mean, stars something. I'm just going to say star something. So you'll see it will immediately tell you, okay, you've changed the file. One sentence has been added. And yeah, there's your file. And again, if you go git status, it will tell you now there's nothing to commit. You're working, your working tree is clean. So you've already committed the file. There's nothing to do here. The other thing to note is if you want to know what commits you've made, you'll find in various projects, and just to take this one a bit home, in many projects, you'll have multiple people working on them. And so, if you load the contributors, you'll see exactly, I mean, Gao has put 392 lines of code on this thing. And this guy has put 9 lines of code. He's also deleted this many lines of code. So you can even see exactly how, how much code people are contributing, even though some people just write bad code and looks like they committed a lot of lines now with ChatGPT and all these other things. But then you can start tracking the actual commits when they happened. What were those commits? You see he updated the deployment. He removed the repo cran. How changed patient to patient, spelling mistakes, created DevOps. So, you've got that trail of all of the things that happened. And if you go in there, you'll see, these are the changes. This is how the file looked. So So yeah, that's really the importance of committing things and just writing clear messages. Git log, it's a pretty cool function that just gives you a view of what's been going on in that folder. It's pretty much like I just showed you on the SES solution GitHub. You know, like there's an author by the name Gao, or that username who changed something on this date. You know, he just put a message * something. So again, very good example of bad practice when you just don't name things correctly. You know, you should be saying, what are you doing? Or what were you doing? In this case, you know, changing a specific file to something. Great. And that's really the important thing there. The other thing to note is git diff. That shows you the you know, differences in the file that's happened. So you know, oftentimes when things break in you know, when you're writing code, is you want to know exactly what differences have happened. Again, once the code is pushed to GitHub, things are way easier to check there. So if I type git diff on mine, it's going to say, well, nothing really is going on here because you've already committed, your changes are already updated, and there's not much that you can expect. It's always good to try to do it after you do the commit as well. So, I mean, this is all that I've just said about staging. You can't just have a file and commit it. You need to stage it first so that, you know, Git knows that that's what it's tracking. And another thing to note is some people do, and I'm just going to create multiple files. I've got just this one now. I'm just going to create multiple files. How, something, whatever, right? The function that I use there called touch, it's just a fancy way of just creating multiple files without going into them. I think most people should have that working on their systems. So all of these files, you know, if you type git add, and then some people do this, they just say git add and then dot, right? So what that means is add all files onto the staging layer. So if I type git status, now you note, you know, Gao has got, nothing has been committed, but he's got all these things that are ready because they're in green. They're ready to be committed. And well, that's bad for many reasons, because if I were to commit this, I'm just going to say messages, I did something wrong here. You know, if I type git log and I check what's been committed, it will basically take all of these files and commit them. And if I've got a repo of 1,000, you know, lines of code, including some very bad things like binary files that I don't really need to be committing, then you run the risk of just messing up that entire repo. So yeah, the best thing to do is just always go git add and name the file, right? Instead of doing just add everything. But if you did that, that should still be fine, because you're able to remove it. I think it's called git remove. Or let's just get help. There you go, git rm. So remove files from the working tree. This is very different from removing files from the folder itself. It's not going to delete it. It'll just remove it from the staging layer. Cool. So we've done that. You know, I've done a couple of things there. As you see, we're always going to be in this one branch. So it should be fine. And then there's some other stuff that you can also have a look at, but it's very easy to figure out what else can you do by just typing git what the verb is and just ask for help, .h, and you'll see all of this stuff, decorating refs and all. You can see what they mean and what you can do with them. It's just good to understand the fundamentals of what some of these things do, but I wouldn't go as far as pushing it. So if I go back to log, there's a way in which I can actually just limit the amount of things that I see, right? It's not always good to do git log if you've got tons and tons of code in that thing. So if I just say git log 1, I'll just see the first, commit that I did. So I'm quite aware of what's going on. So again, just some interesting things in there that you can do. Great. Now just to check on everyone, are we still okay? Am I moving too slow, too fast? It's always good. It's very difficult when you're having these things online because you can't really see people. So you just hope that a voice out there screams we're doing great. All right. Okay, I see your hand, so I'll assume that's a yes. Great. Now let's get into the next one. Then we can start doing some more in-depth examples. So, now you may want to know, okay, well, I've got these changes and the history around the changes. How do I identify some of the old versions of the file? How do I review those changes? And is it possible to recover that file? So maybe you just want to go to a specific version. And the nice thing is the reason why you want to do that is if you see here, I said here I did something wrong here, or I was changing the color purple or whatever, then maybe I want to go back to this version of the file. And it's always good to just keep checking yourself, right? Like where are we now? So let me just go back to the file, Mars. Okay, so everything is still okay. Could and dry, didn't change anything there. That's good. Let's just create a different version of the file. I'm just going to say nano Mars, and then I'm going to add some new random things. Control X, Y to save it. Git status. Great, the file is there in red. That means it's not ready for staging. Git add Mars. Sorry, the command was I did git status and then I did git add. So if you check your status now, it should be in green. Therefore, you can commit. Added a feature to do magic. Sure, something is wrong there, but there you go. So now if I do our git log, there's a bit more to actually work with. There's like, 3 variations of this. You'll see in my file now, I've got the new thing that I've just added. So that's what we're going to be tracking and seeing if, we can always go back to that old other version. So yeah, how are we going to tackle this? I mean, we'll just start with the use of identifiers in Git. And then we'll do the simple, let's just identify it by the Git number or the commit number or whatever. And then just look at comparing the different or the various files that were changed. It's really difficult to do it here, and like I would not advise it on anyone. I guess the reason we're doing it here now is just for the principles, but it's much better if you do it in an integrated development unit that's easy to work with, like whatever it is that you are writing your code in or you writing your flat files in. So let's start with the first one, right? The commit identifier. So you'll see here, you'll have like head, main, or whatever. So it can basically help you understand the recent commits in that working directory. So even though like the time that we were doing it, actually we haven't actually done it yet, there are ways in which you can just check this out. So meaning, let's just have a look at the current file, but you're not really changing the file. And then there's a way in which you can revert the changes that you've made to the file. So you can think of it as, you've got, once you've saved this file and you've committed all the changes throughout, all of that history can be tracked, and you can always go back to that point in time. So I'm going to try this git diff head. Mars, the text, whatever that thing was. I'm trying to find out why my diff is not working, because I did not change. Okay, so let's just add a few other things in that file. Nano, Mars, text. So I'm just going to add a few things before I commit. I control X and then Y. And then I'll just go ahead and do a diff. Git, sorry. Okay, so something is there. Geez, I would hate to be programming in the 80s and this is all you had. So you'll see when I use the diff and I use the identifier, it will immediately give me, I mean, it should be a lot different from if I just do the differences. So you'll see, just trying to figure out now. Okay, so with this one, it should be, yeah, they're going to be the same because I just changed it once. So if you were to change this thing multiple times without committing, but you just keep changing, well, then you get, different identifiers. And I'll just show you just now how the identifiers stack up before I start using them. So here you'll see basically that identifier will tell you exactly what version of the file that relates to that repository, or the changes that relate to that repository. And then you can always choose a specific identifier to be able to pull out the file without having to, revert your changes. So let's try all of that and not just talk about it. So if I try to get the git diff of the first identifier, I'm just going to do HED, and you'll see why some of this is super important when we tackle branches and then Mars. So the only reason I'm copying this is because I don't have tilde on my MacBook. See what happens when I do 2. Call be different. Some of the new differences. Yeah, I think mine is always going to be different because I changed it only once. Yeah. So let's continue with the example, and then, hopefully as and when I'm changing it, we start to see more than one identifier. Cool. So we've done 2 things that are maybe important. So we get diff so that you can see the different versions of the file and the changes. And then we also did log, where we get the logs of the different changes that we've made. But different changes. And then we also got in log the commit ID. So remember that ID that you could then use. This is what we're going to do later. If you want to take that commit and just revert back to that specific point in time, that specific version. So that was commit ID. And then now we're just going to be looking at a different one called show, right? So even though the other stuff is great and you can see the differences that you've committed, sort of, between the different files. So the file was at a point in time 1 and at a point in time it was 2. So just in that file, what were some of the changes that happened or the differences between the two files? Now you want to know, well, what is the difference between the actual working directory and the files in there. So for that, we're going to use show. I'm going to try to show you how that looks without even adding an identifier. So if you say show mass.text, then you'll see it pulls out a ton more information than if you just use git diff. And so there's a great way to also pull out specific information about the identifiers themselves. Great. Now we're going to actually start using the actual commit IDs. So if I take at a point in time, so I'm going to take this commit ID. So as you can see, there's a commit ID over here. And then just try using git diff to see the differences in that commit ID. Always use the file name at the end. Then you will see for that specific one, it'll just give you all of that information about what changed. Now, you're doing it here, like I said, the file is not really that amazing. We haven't done any big changes there. But if you go to a project as an example that's already been pushed, I'm just going to take this example. Then you should see that I hope I did make a lot of changes here. Otherwise, you're not going to be able to see any interesting thing. Okay, I also didn't make a lot here. And all this time I thought I wrote a lot of stuff. But you'll see, I mean, it will be much clearer and you can sort of see the pluses there. This is when you add the code. If it was red, this is how you delete the code. So it's much cleaner and readable here. Even the branch that you're in is more clearer and you can see exactly where you are. But yeah, if you're living in a shell script somewhere and accessing a remote machine, it's always good to be able to do it on the fly as well. So the other thing that you can also do is just use the first couple of characters to do this. So instead of using this entire line, just using the first few characters. And all of this stuff is pretty much what we've discussed. And then you can check it out, right? So the checkout verb, what it does is it takes that specific version of the file and then checks it out so that, that's now the version of the file that you're going to see. So if I've got all of these things here, if I check the new version of the file, if I check out a different version of the file, then I should go back to the point where I started maybe adding information. So let's just take an example with here where I knew I did something wrong. So I'm just going to take that and then do a git checkout. Just do a git checkout of the file. So you see, it will tell you it's updated the path. Now, I hope that if I try this now, it will. There you go. So the file has changed. We're now at a different version, and that's because we've checked it out. So you just take that file and revert back to a point in time, and it makes all of these changes in your file already. You can do the same by, again, saying, actually, I like where I was, and so let me check out that. And then it will tell you again, we've updated the path. So if I check now, you see there's more things where I was starting to add some random things. And you can keep doing this, I mean, until you get the file that actually works. And oftentimes people know, either when did things go wrong in case of code, or when did I have the right working version of this document. For me, what I found is it helps a lot when, especially when you're doing research and you need to do some simulations, because, one single change of code, because, you out there working and excited about what you're doing, and you change something and all of a sudden your simulations are failing. You can always revert back to a point in time when your code was working perfectly and just revert. Great. So as you can see here, don't lose your head. Always make sure you've got that. It's super important. I think some of these things here we can do, but I'm just looking at time and I'm trying to cover everything. This should be a 4-hour workshop. Are there any questions so far? Gamo?
Hi, how? I have a question. So if you make a change, not adding a new line, but just change the word, like if it's a spelling error, and then you commit that. So when I do that get diff thing, somehow it does not pick up the difference between the two because I just changed the spelling. I didn't necessarily add a new line.
Oh, so like you see, I've got sum here, and then I just change this sum to something like this.
Yeah.
Is that what you're saying?
That's what I did.
Okay.
It doesn't show any differences.
That's weird. It should show you a negative and a positive. So.
Oh, okay. Now I actually got it. Thanks.
Oh, brilliant. Brilliant. Yeah. Brilliant. So, and I mean, it's great that, like, I hope yours, if you're using Windows, it also has this like color coding, nice thing about it. Great. So I'm gonna move. Yeah, and I mean, you've got access to this, free content that's licensed. Can always access it at any point. Here's the very important thing, right? This is probably my best thing ever. Ignoring things. It's not always that you want to commit every single thing, or every time you do a git commit and you've altered 10 files, now this thing is going to GitHub with 1,000,000 files that you didn't want to commit. A typical example is, let me actually show you what a typical example would look like. Right. I'm going to take now I'm just using, by the way, this is not for what we're doing now. It's just for example's sake. Like if let's take this one, right? Like if I take a bad, just imagine you're in this bad project with all this humongous code. There will be things in there that just get created as a consequence of you compiling code. Unfortunately, I can't find interesting ones now, but there'll be things that just, like you don't really want to commit these things, like they're necessary, like PYC files in case of Python, or another example is those passwords and secrets that you don't want to commit. I've actually been in a situation where I've accidentally pushed a secrets file. The file has secrets about databases and all these things, and so we had to go change all of these passwords, because once it's committed, it's now in GitHub. You can go find it there. It will live there. And so there had to be this massive wipeout of passwords across 10 different systems, because Kha has accidentally pushed a secrets file into a code base. So how you do this is you need to create a file that is known as git ignore. It needs to have a dot as a preamble. So you can just do nano.gitignore, and then it just gives you that, gitignore file. There you go. So now I've created the file. I'm just gonna wait, is it there? Sorry, let me just do it like this. Okay, so now you've just created the file. You'll note that it's not there. It's because you started with the preamble gitignore, but that's fine. So let's create it and then put something inside so that I can explain it better. So nano git, ignore. I'm going to tell this thing, I don't want to see PYC files is a pretty good example, but I'm going to choose something that I already have, or I'm going to create. So let's say ignore all CSVs, right? So you'll just say .csv. But if you don't want to name all of the different files that it should ignore, you can just say star, and it will basically know, okay, anything that has the extension file .csv, I'm just going to ignore this. Like, it's not going to be important. And then I'm going to save this. All right. So what you've now done is, created this file that now Git already knows to go look at before it tries to stage or commit something. It will basically know, oh, okay, I need to first look at this. And it's always good to also add this file as part of the, as part of your code base. So this file is also going to live wherever your code base lives. Like if you look at a lot of the stuff that I tend to work on, I'll have this file called gitignore, and you'll see there I've got, our history. You don't want to keep this. Our data. Like I don't want to push data that is probably sensitive to GitHub, CSVs and PNGs, and so all of these things that I know I don't need and they should not be part of the code base, I'll just add into this file, and then I'll push the file. So what I'll do here is just add the file as well. And we're done. We'll just commit everything along with it. Remember to ignore files. All right. If I type git status, the thing is there. I've made some previous changes to Mars, if you remember, that Gamo asked me to do. So that's still there. Now, when you add stuff, it's not going to allow you. So if I add Mars now, like git status, did it? Ooh. Oh, okay. My git ignore is actually only rejecting CSV. So I didn't say it should reject TXTs. So if it was TXT, then it shouldn't allow me to do this stuff. And because I've already done it, it's a bit of a problem. And if you want to force it for some weird reason, you just changed your mind about one of the files, this one you really need, then you can always use the option F, which in the context of most Unix commands always just forces things upon Git, right? So if you just say git add Mars, and then you just add the option F, it will just force it to do exactly as you please, as you want. The other option, I mean, is just to say, well, what's the git status on some of the ignored files? Again, if you want to override it, which it usually doesn't make sense, but sometimes it does come to that. Great. So that's ignoring files. I would say that's a big thing there. I don't think there's any key other important thing to know about git ignore files. Are there any questions? Great. I will take it everyone is happy. Now, the next thing that we're going to do is remotes. Remotes, basically, I've been going back and forth to this repo as an example, and that's because it already lives on GitHub. So the idea of remotes is where this ugly thing meets this beautiful thing, right? So basically, if I wanted to take all of the things that I'm doing here and push it onto here, how would that work? And this would happen in the case where, for example, you're running a virtual machine, and maybe what I'm doing here lives in Netherlands or wherever, and then I need to now push code in a in a cloud solution that people are using, like GitHub or GitLabs. Then you can't do it unless you've authenticated these two things to work together. And that's what we're going to do now. If you manage to install GH, it's often like super easy. Like if you do a brew install, by the way, in Mac, just do brew install GH, I suppose. It will just install the thing. Or if you are on Windows, I think there's an option to do it with wget, but I'll let you, at some point, when working through the notes, just try to do it yourself, or use, the shell authentication version, which is already outlined in the notes as well. So for this purpose, I'm just gonna try to authenticate. I mean, this GH thing on itself has a whole manual around it. So, it will tell you exactly how to download the thing, how to install it, what the different commands are, but I don't want to overload you with commands. So, happy if you just want to have a look at this one and how it works. and maybe appreciate the integration, and you will do it at your own time as well. So there's the brew install for Mac, and if you want to do it in Python users, you can use Conda. This is all these versions. Okay. Oh, it's available through Winget. Yeah, I think that's the most common one. Really apologies for using this MacBook. It tends to make things easier, and so you don't spend a lot of time thinking about what it would take to actually install these things. So I'm just gonna go GH authenticate, and then you can just do a simple login, which allows you to choose, okay, how do you want to access this thing? Is it through a secured HTTP or through a SSH or shell? The safe one is usually at HTTPS, so I usually just do that. And then it will ask me, do you want to authenticate your credentials? I'll say yes. Do you want to log in with a browser? I'll say yes. And that should open a browser that will give me this option to enter this code that I get from the command line. And by virtue of doing that, it will tell me exactly where it's coming from, and then I'll just give it access, confirm access, and then it will authenticate on my phone as well. So for those of you that tried to install GitHub since 2023, they've stopped allowing the use of GitHub without multi-factor authentication. So if you're struggling with this, also there's two ways in which you can do it. You can either use Duo or whatever authentication application that you're using. Either or should work. So I'm just going to try with mine for the sake of this demonstration. And again, it is very clearly defined in the notes. So at some point, it's worth trying yourself as well. So I get a weird number that I'm going to try to punch in here from my phone. And it says, congratulations, you're all set. So just to show you how this works, right? If you are authenticated, you can now create repos and use them in the command line. So as an example, on GitHub, if I were to create a simple repo, so I'm just going to go here to repositories, and then I'll create a new one. And then I'll just call it for the sake of workshop. And then you just keep it public. The moment you create a repo on GitHub, it already gives you an option to either collaborate with someone. So if you want to work with other people, and then it gives you a couple of commands that you can then run as well to make sure that you can create this on your machine as well. So if I take all of these things and I just type them out, I can already initiate this here, but I've already done all some of these things, so it's probably not going to allow me. You can also pull it. So this one that you've just created, if you click on HTTPS, it will give you the option to copy this, copy this URL, and then on your computer, you're going to use the command git clone. So you're cloning the repo that you just created, and then you just paste the URL. And you see it tells me, it appears you've cloned an empty repository, which is fine. And you can see that it exists now for the sake of a workshop. If I go check in my planets folder, you'll see I've got now a repo. In there, I can start doing random things. So for the sake of this example, let me just take all the stuff that we've done and just throw them in there, in that folder. Now that you've got this in there, you'll see if I type git status, it will sort of tell me, well, you've now created all these files that you haven't committed. And then I'm going to do a really bad thing of just adding all files with a dot. Does not have a commit checked out. Oh, okay. My apologies. Git commit m initiate repo, and then git add files. Can I commit twice? To update, we will commit, discard the changes in the working directory, untracked, ds.store. Okay, so I was not supposed to do that. I was supposed to first commit because the file is there. And if you follow all of these instructions, I mean, you'll see you need to make your first commit first. But if I do a git log, I mean, I can see exactly what has happened inside this repo. Okay. Now, oh, shucks, I'm so sorry. I didn't even enter this repo to see what's going on. So I'm just gonna dive right into the repo, do a git status, and then you'll see I've got a couple of untracked files. Add them, works, git status. You see now they're all green. Then I can commit the files, new files, add it to this thing. Then, it'll give me a couple of files that it's actually created. And now I'm going to do one last thing before going back to the notes and just try to push them here, right? Because I'm authenticated, if I do git push, it should essentially move the files to my GitHub account. It is much easier, again, like I said, if you're doing this in your IDE or you're doing this in your GUI. But I'm going to try to do it here. So generally, every file or every repo that you get is going to be named origin for some weird reason. That's just what Git calls every other repo that is remote. So this repo that lives in GitHub, it's called origin for the sake of knowing exactly which cloud service to push this to. So in this case, the SaaS solution is GitHub, and it's called origin. So if I type origin, and the main branch is main, it knows to push this to GitHub. But if this were something else, it wouldn't know unless you configure it to be something else. For example, if you are in two projects, actually, this is a perfect example. Working in a consulting company and doing work on your personal repo internally that feeds into your client's repo, you will have different remotes. So one remote will be the origin, and I'm going to go a little bit deeper into this before we complete. And then the other one, maybe on the client side, is called, I don't know, Google. So you always know when you push code or when you pull code exactly where it comes from. So if I were to refresh this page, I'm expecting to see files. Oh, there you go. So these are all the files, as you can see. You know, just by having pushed this into the into GitHub, you'll see that these are all the files that we created. You can click on them. Mars, I think we messed with quite a lot. So there should be a couple of things in history that we can have a look at. And there you can see all of them are in there. And this is much nicer to then work with from here to see differences, to compare against previous versions. And so, you know, once things are on GitHub, that's generally when people start rating code, giving you comments. So someone might come in here and say, you know, looks good, even though they didn't check my code. You know, rating 5 out of 5. Comment, done. Right? So you know, okay, there's one comment in my code, everyone loves it. It might actually end up being pushed into production or whatever. But like, there's a complete review process that people tend to follow when working with multiple teams in, you know, large projects with multiple code bases. So yeah, I mean, I spoke about a lot, but all of this stuff is here. For example, you know, how you set up the repo, how you create the repo, you can call it whatever you want to call it. You see here, what we did was created it directly from our local machine, and then we pushed it onto GitHub. There's also ways where you just create it on GitHub, just pull it, work on your machine. And then GitHub also offers you the option. You'll see if you go to any repo, GitHub generally gives you the option to pull an existing code base, either by downloading the zip, which is not generally ideal, or opening their GitHub desktop. So, you know, I certainly prefer just using the GitHub desktop because it will make it super easy. If you just, you know, open that, it gives you this nice option over here, and you can just press clone. All of a sudden, the thing is cloned. If you, you know, you will see there will be nothing in there because it's not a, you know, generally this is not a file browser, but you've now got the file, the repo, and you can start doing stuff. Just say, change something, and then press commit, and the stuff just goes onto GitHub. So this is way easier. But like I said, if you're working off of the command line, then just knowing the fundamentals and the basics helps. Great. So I actually didn't realize that we've already done all of the, you know, connecting to the local repo and all of that. Like I said, there's 2 versions. There's HTTPS, and there's also, and then there's also SSH. One thing to note is that my repos, you know, I've already assumed origin because I know I'm just using one remote, which is GitHub. But you'll see here, they add the actual remote, which is the you know, the URL that I mentioned before. So if you add it, that means you either didn't have it or it was just giving you issues. But as you saw with mine, it just immediately worked. And then what you can also do is, you know, just check that your repo has been properly set. So in my case, if I type git remote, I can already see I've got this origin, you know, which is the exact site that the URL that I used to pull the repo. And so I can get the code there. I can also push it there, whatever changes I make. So yeah, I mean, generally I wouldn't advise for SSH, but if you're working with if you're working with virtual machines somewhere in a remote area, then it's probably a good option to go with. So if you do want to configure SSH, again, it does get a little bit messy, especially if you're doing this for Windows. So just try at all times to use the secured HTTP. Great. I think that's the most important part of this. Like I said, the GitHub GUI you can download. It does make your job a lot easier. You will note in most IDEs, as an example, because I'm just worried we might not get there. I think I was using Visual Studio Code. They do have these things already ready. Like if you just download Visual Studio Code, it already has, version control. You can clone from GitHub, and they've sort of made it easy in such a way that you can immediately see everything that's on your, on your repository. And they've made it easy as well to authenticate. And I think that was one of the most difficult things to do back in the day. The same with RStudio for some of you that use RStudio. Oh, I think I don't have it. But the reason why I show mostly code around, doing version control is simply, personally for me, I mean, doing version control on, like Word documents is probably overkill. And that's my own opinion and reflection. There's much more sort of complex, I would say, bodies of work. Like if you're dealing with LaTeX, which has multiple things going on, where you want to probably version, or you're working with multiple documents, like I said, that are really, and it's a big project and there's multiple documents involved. And, maybe then you want to go through the hurdle of, using Git. But yeah, if you are using RStudio, I mean, you'll see as well, there's an option to actually set up the project. I don't have an active one, so I can't do that. But you're able to basically manage your repository directly from RStudio, and it will also be a click, drag and drop. It's not. I mean, it's not going to be code unless you need to write a commit message, which is also really not code. Cool. Now I'm about to end, so I'm just going to try to spend the last 5 minutes just addressing this one as well. Collaborating is like one of the key reasons really why we use version control. You're working with multiple people. How do you then collaborate? How do you clone repos? How do you push into common places? And I'm gonna try to do this on over here, if I can just delete everything. So generally how we use Git and GitHub in software development. So you'll have a base repo where all of our code sits. So we know, everything is here. Our code is all here. I am, let's say I'm a data scientist. I'm working with a DevOps engineer or whatever, or a software engineer, right? And then there's like multiple other people that tend to get involved. So what you want to do when working with like multiple people is, I'm going to wake up in the morning and I'm going to go to Jira or whatever, like, whatever collaboration tool you use. I'm going to go and wake up and see, okay, how many tickets do I have? What should I be doing today? Oh, build a feature, build a model. Today I need to build a a model. Today, I need to write a documentation for something, whatever it is, right? So given these tasks that I have, what I'll do is I will, in the morning, pull the code base, right? Even though you still have it. Like, for example, in my case, the code base is still there. But in the morning, I'll do a git pull or git fetch, just to see, has there been any changes? Should I be worried? If it's nothing, git fetch gives you nothing, that means there's really nothing going on. If you do a git pull, it will generally tell you, oh, your repo is already up to date. No one has actually touched the code base. And then once I do that, then I know, oh, great. Now I'm starting from ground zero. And the reason why you do this is because you're avoiding conflicts with, changing people's code or, doing the same thing or with someone else on the same spot. And now you've got all these conflicting files that you need to merge. And then, I'll go and pull out my keyboard and start typing stuff and, being busy that day. And then when I'm done, I'll need to then commit the code back, commit and push. So I fetched. And then when I'm done with my code, I'll commit the code. And then I'll push it. It's generally advisable to push smaller chunks of code because if you break something, you know where to fix it. So you push everything. It doesn't matter where it is. It could be a dev branch or like however you work. The same is true with everyone, right? Maybe the DevOps engineer is working in a different time zone. He pulls the information not at 8, but at 11. What he's going to find is that something has changed. So you'll see if I go here, I can change the file directly on GitHub and say delete all code. So I can actually do that, like change things here on the fly, changed stuff on GitHub. And so once you've done that, when he wakes up and he does a git pull, you'll see it changes now. It will tell you, well, a couple of objects have been downloaded, and there's clearly been some changes, about 4 plus things that changed. Something was deleted, something was inserted. So now this is the new changed code base, right? If I go in there and I check Mars, you'll see it says now delete all code. So I've pulled a new version of this, and so that's why when you start any piece of work, the best practice will be to pull it, do whatever you need to do, and then push code back. And then in the background, there's a lot of things happening here to make sure that the code is working, to make sure that, you following the right practices. And, that's not really the main aim of this conversation today, but this is generally how you use it in a, software development cycle. It does get a little bit more complex than this, but yeah. And obviously where whichever organization or whichever, or you doing this for yourself, version controlling for yourself, the main messaging today is really that you've got tools that have abstracted so much that you don't have to worry about. But it's always just good to, understand what to do and what not to do. Don't merge files unless you know what's going on. Don't, delete things that, well, deletion is not really a problem because you can always recover stuff, but you can totally mess up repos. And I've seen it happen quite a lot of times when you're collaborating with people and you just completely mess the thing up. Commit at all times, stage at all times and commit. push code before you go to sleep. It's a widely accepted joke that we never know what's going to happen to you tomorrow. So it's always good that you've pushed your code before you go to sleep. But yeah, that's really the crux of it, given the time. I think it's one of those things that actually needs a longer workshop in person. But yeah, that's it from me, and thank you very much.
Thank you, Doctor. All right, I think I'm going to start opening up the floor to any questions. I'll lead somewhere with my questions. I liked that, especially towards the end when you started talking about R, because we play around R and Python and VBA a lot. So I'm wondering if also VBA can be integrated with GitHub. Is that something that's possible?
Yeah, I mean, I guess it depends where you put the code, right? Some people, what they tend to do is like separate out the VBA code with the actual Excel.
Yes.
I wanna open an Excel, but like I'm super afraid of like opening like something here and like but anyway, so generally when depending on where you keep the code,
yes,
I mean, code is just a flat file, right? Like, so you can definitely save it on GitHub, but directly from Excel, I mean, that's an interesting one. I don't know actually.
Okay.
Because that would be really amazing.
Okay. That should be interesting. Perhaps I'll also, as I play around with this thing, if it's possible, then.
What are you using VBA for?
So we generally have like repetitive tasks or integrative tasks. So let's say we are trying to model something specific, but we want to replicate the parameters of the model.
I see.
Stuff like
I
that.
see.
And then we have a bunch of submodels that we have to run. So we would generally use it for those kinds of things. So
I see.
yeah.
Do you see though? It's not like a very common thing, but they have a way of forcing it. Oh yeah, you see. So
So it
but
does.
yeah, you're gonna be forcing it for sure.
Oh, I see. Okay.
Yeah. So if you edit them directly within VS Code, then you can use this to edit to get. Yeah, there's ways. There's ways.
Okay. Okay.
So that's good news.
Okay. And is this like an open platform, like GitHub, or is it owned? I'm just asking also for licensing reasons and stuff. Yeah.
No. So this is absolutely free. You only start paying once you need more private repositories. Then you start paying. But what happens is, I mean, I remember I once did this, right? Like if you use your school address, then you can actually get a better package than the one I got. And have more private repos. And, you know, some of the things you want to keep private, like you don't want to put everything out there. So yeah, but it's absolutely free. Git is free as well. Like, I mean, everyone can use this. It's like Linux.
Cool. Because I'm asking mostly because especially in our organization, we tend to want to, hold someone accountable if something goes wrong. So that's the only hesitation we have with free software is like, who do we hold accountable if something, who
I see. No, no. There's so the likes of GitHub as well. Like you might need an enterprise version, but like there's like various packages to it. But if you're doing very important things in the organization, then you need those extra capabilities. So for example, if you've set up a repo correctly, you should be able to see if somebody pushes code, what is the security of this code, like the, just profiling the, whether the code is secure and a lot of other stability and actions as well to check if it, passes various unit tests. And so, there's all these things and like actions to check if the person is writing code according to PEP 8 standards, if they're using Python. I don't know R standards. I haven't seen Yeah, but like in more
I get your point, yeah.
sort of mature ones, it's yeah.
I see. Okay. Oh, no, this is great. Okay, I see a hand here. Gaonyalelwe. Go ahead, man.
Yeah, cool. Thanks, man. So I have a question. So I saw that
Yeah.
those devs and data scientists, but I have a different scenario where it's me and my supervisor, right? So
Yes, yes,
we
yes.
are I've been using, what is this? With LaTeX, the online thing,
Yeah.
to write my thesis, but somehow my supervisor
Yes.
wants me to be able to. So we have a remote server on which, if I use a LaTeX document, I'm supposed to commit stuff there so that he can be able to look over the stuff and make change.
Okay.
So it to be the push thing but so far I've not used that. So I'm just wondering how do I move from overleaf? Like, do I just work with a text file on its own, or do I just pick up everything else? And then I would also have to manually set up the ignore files that usually don't need to be updated, that come up with your
Yeah.
text folder thing. So this one, and also when you create a directory, do you have to always, what did you use, brew something to within the directory to get access to GitHub, for instance, which is your remote thing? Like we created
Oh
Planet
yeah, I see what you mean. I see what you
folder
mean.
thing. Did we have to get the planets folder? Do we have to get installed GitHub for every repository, or what is it, a folder that you create to be working from?
No, no. So the short of it is, so I'm gonna start with the last one. I mean, just I've got too many CVs here. It's not good. I love my job. So you I mean, here in Overleaf, generally you okay, you've got the version history, and okay, if they want access to it, I mean, you can easily merge this with your repository. I'm just surprised that it's not offering that option. But look, I'll have a look for you, and then I'll just contact you on the side. But if you take just the files in here and then you just set that up as a repo, if that's the approach you're taking, I'd rather work offline, because then what you can do is manage it using this, GitHub, the GUI. This is like super easy to work with.
But you don't want us to go because it's not private. Is GitHub, or because we have a different server that they created at the university that you can saying, are you saying you could also use it? I don't think it's as user friendly as this GUI.
What, the server?
Yes. That
Yeah, but I mean, the server, how do you, the same way you authenticate to that server, you can use a GUI to do the same.
Okay.
It doesn't have to be this. I mean, it could be anything. But I'm just saying, if you're doing this every day, I mean, you probably don't want to do this. You want to use something that's a bit easier.
Exactly.
And then as and when you're pushing stuff, but I'll connect with you at some point offline. Happy to explore it with you.
Sure. All right. Cool. Thank you.
Cool.
Oh man.
I do definitely think that there's a lot of room for more workshops with you, Doctor. So I think I think a lot of people will be keen on.
Yeah.
So I think if you're definitely available, you can just let us know. Perhaps we can set up another one. And then if the guys are also keen, perhaps maybe we can even throw some concepts. But definitely for me it'll be R, to see how that works, how you can use that, and maybe so that'll be great. Okay, guys, do you have questions? There's still last rounds of questions before we close. Okay, so while we're waiting for the one last round, Doctor, do you mind if they contact you directly, or should they rather contact me, and then so on and so forth? I'll just post my email address in the chat so long.
Okay, cool. Yeah, I mean, happy that you share my Gmail as well. Got any questions on stuff?
Okay, cool. And then for the guys out there as well, this video is recorded, so it will be available on the YouTube channel. I've also put the YouTube channel in there as soon as it's been edited and stuff. Yeah. Okay, guys. So if there is no more questions, okay. So, Doctor, are you gonna put it in the, or should I put it in the chat as soon as I get your email address? I can just email it to everyone as well.
Oh, is that? Oh, okay. Yeah. Let me just put it in the chat. That's probably easier.
Okay, cool. But this is so cool. I like the interactiveness, especially from a business perspective, how you can interact div departments and other departments as well. Because there's a lot of silos. That's one thing I've come across.
Yeah.
Especially, working for the organization, it's 100 years, but there's a lot of silos and you get stuck somewhere and then you end up on Stack Overflow trying to do this. But this is a platform that answers that you can collaborate with other people.
Yeah.
So this is very cool. Okay, guys.
Amazing. Thank you so much for the host and the hospitality.
Thank you very much, Doctor. And like I said, looking forward to another session with you. If we can lock you in again. And thank you guys for the audience as well for joining us this evening. And we officially close the session. You guys have a great evening, a great night ahead. Thank you.
Amazing. Cheers, everyone.
Cheers, guys.